Alrighty, howdy folks. Welcome to Engineering Economy class. Let's start with this chapter 1 introduction. And this course is uh, Principles of Engineering Economy. By the way, my name is Sam Narimetla. And so, Principles of Engineering Economy. One of the things I wanted to tell you is as an engineer, you definitely would need this course and the content it talks about. You have to have a fairly good understanding of all the stuff that we're going to be talking about in this class. The way I'm trying to motivate that is by saying, please believe that your decisions as a working engineer will not only depend on the technical superiority of your designs, but also on the economic feasibility of your projects. Recently, I got a chance to talk to one of my classmates, engineering classmates back in India. And he works for a big oil corporation. And so he's a marketing engineer. And I asked him, do you use this stuff? And he goes, man, just about every day. His whole life revolves around and doing this stuff. So, for instance, what do they do? People like him. Um, their clients often are different gas stations, right? And let's say a gas station needs 5,000 gallons of gas every day. Okay. And somehow he needs to not only supply the gas, but also charge them certain amount. How much should he sell the gas to the gas station for? That's a decision he needs to make. And one day he got a decision, he had to make a decision about a request that said, we need some god awful number of gallons every day. And he's like, what in the world is this? Who is this? And he became a little suspicious and he wanted to check out. And he actually physically went to that place to speak to whoever the boss was. And he found out that they were actually really in need of so much of gasoline because they were doing a tunnel boring, uh, and so they were drilling underneath the underground, so so that they could lay this railroad underground railroad system in a big city. So that's going to consume a lot of gasoline. And he had to decide how much to charge these people per gallon. And he said they use a concept called internal rate of return. And as soon as he used that particular term, I kind of jumped with joy because that is, in fact, one of the things that you will learn in this course. Okay. So, all that story is to say, hey, please take this class a bit seriously. All right. Okay, let's move on. This is the reason you must grasp. All right, blah, blah. Good. One of the first concepts you need to understand is what's called time value of money. So let me motivate that this way. Consider the following scenarios. I'm going to give you a few different scenarios and let me see what your response typically is. I ask you to give me $1,000 and I promise to give you back that $1,000 after 1 year. Would you lend me the money? I give you 1,000 and after 1 full year, I give you that same $1,000 back. And probably not, right? Hey, I got to use this money for something else, and so you may not. Of course, if it's a really good friend, you will, or your family, you might, right? But then, if I ask you to give me $1,000 and I promise to give you back $10,000 after 1 year, would you lend me the money? Dang, I mean, you are multiplying your amount by 10 times. Of course you would be, right? Almost certainly, yes. How about 2000? Yeah, that's not bad. Doubling in 1 year is not so bad. So you might say yes, right? What about 1100? See? So 1,100, I'm just making $100 after 1 year on $1,000. Maybe not. Maybe you would, maybe not. So it depends, right? Um, and what are the questions these previous scenarios raise? The first question it raises is, does $1,000 today have the same value for you as $1,000 in a year from now? Right? Even the numbers are the same. Is it same value? And the answer is no. Okay. And in order to understand all of this, we need to start with the first rule of cash flow. And before I talk about what is the first rule of cash flow, let me go ahead and define as to what cash flow is. Okay. A cash flow simply refers to money received and money dispersed. So there is a particular way that people represent graphically how much money is coming in, how much money is going out, and things like that. And that gives you a nice visual representation of the in the cash flow in your firm. Okay. And economic decisions by institutions and individuals, right? Even strictly speaking, you and I, we kind of have to have a cash flow. That's a better way. Not all of us necessarily plan everything and have a budget and keep track of money meticulously, but it's definitely a good idea if we could. Okay. All right. Look, now the first rule of cash flow is money has a time value. Like I said, $1,000 today is not the same as $1,000 in a year from now. That's because time has elapsed and the value of money has not changed. You went from 1,000 to 1,000. That's not good, right? Because money has time value. TVOM, and you will quite possibly see that abbreviation quite a bit in the next few sections. Now, I had asked you if it is 1,100, would you lend the money, right? So the second question that pops up is, what is the smallest amount I need to return in a year for you to say yes? It certainly depends on an individual or a firm, but would 10% be okay with you? Like a gain of 10% in 1 year? Meaning if I give you $1,000, if you give me $1,000, I give you 1,100, that is 10% increase. Would that be okay with you? What is that smallest amount? Right? And that's another question that arises. Let's say 1,100 is no, but 1,200 is okay. Right? That's your way. Man, I have to have 1,200 bucks. Cool. And then you can calculate time value of money for this $1,200 in a fairly simple way. And this is not quite rigorous. There are much more rigorous ways of finding this time value of money, but a simple way is future value minus present value divided by present value. So that is the time value of money for you, lowercase I. Okay, for this $1,000 and $1,200 thing, can we figure this out? Future value would be 1,200. Present value is 1,000, right? And so 1,200 minus 1,000 divided by 1,000. Well, strictly speaking, I should have said that $1,200 minus $1,000 divided by $1,000, and the dollars and dollars, they all cancel and the units cancel, and this ends up being just a simple number, a dimensionless number, 0.2. So, so 0.2 or 20% per year. That is the time value of money for you in that instance, where you say, I have to have a smallest amount, the minimum amount I have to have is 1,200 when you say on $1,000. You are saying that your time value of money is 20% per year. And that depends on an individual or an individual institution. Cool? All right. But there is such a thing as time value of money for just about every person and every institution. I want you to know that. Okay. And other terms for this TVOM, time value of money, are interest rate, discount rate, hurdle rate, minimum attractive rate of return, MAR, and cost of capital. Guess what? We will use all these stupid terms. It's not like you can escape this. That kind of reminds me of derivatives. You can say find the derivative, take the differential, find f prime, find y prime. Man, all kinds of ways. It is the same thing here. All right. Okay. Next, observe that I equals f minus p over p. And so would you agree we can multiply both sides by p? And in that case, we get f minus p equals p times I. Cool. Now, my whole idea is, in that case, can we figure out f? Yeah, add p to both sides and you get p plus ip. That is the future value. The whole point of me doing this is the future value is the present value times 1 plus I. I is the time value of money or the interest rate. Okay? Where f is the future value, p is the present value, y is the interest rate or discount rate. And a discounted cash flow, I need to define that. That refers to movement of money forward or backward using the interest rate. What? So what this is trying to say is $1,000 now. Can you move that $1,000 to a year from now? What do you mean move the $1,000? All it is saying is, can you find a future value of that $1,000 where you're talking about the future value, right? So you're moving money forward in time. The answer is yeah, you can. The present value by using this formula, P future value is present value times 1 plus I. That's all it is trying to say. At the same time, you can also move money backwards. If, how does that work? Okay, check this out. Mm, if you say, hey, in a year from now, I have to have $2,000 and I can loan some money so that I can get $2,000 in a year from now. And the interest rate I can get is 10%. Are you following me? 2,000 in a year from now, interest rate is 10%. Good. How much should I loan or invest today so that I get $2,000 in a year from now? With time value of money interest rate being 10%. That's the idea. In that case, you would be taking and pulling that money backward from year from now to present day. So that is also a possibility. So the second rule for the discounted cash flow rule is to move money forward one time unit, multiply by 1 plus the interest rate. This is only talking about one time unit. I want you to pay attention to that little part. What about here? This says one time unit. What about 2 years, 3 years, right? And why don't I say year? Because the time unit need not necessarily be a year. It could be a month or a day or a second, anything. So to move money forward one time unit, whatever you choose, when you know the interest rate for that time unit, multiply by 1 plus the interest rate. Cool? All right. Let's change our original problem slightly. If I promise to give you $1,000 a year from now, how much money are you ready to give me now? Right? This is a slightly different version of what I was mentioning a second ago about $2,000 and all that. So I promise to give you $1,000 a year from now. So now I'm asking, how much can you give me now? And your TVOM is 20%. So here we are pushing back. So we have the future value f to be 1,000, I to be 20% or 0.2. And so the present value should be what? right? That's the question. Well, can we figure from this one out? F equals P times 1 plus I. I hope we know enough math that we can do stuff like this fairly effortlessly. Well, you want P now. Cool. Divide both sides by 1 plus I. So P equals F over 1 plus I, right? So that's the point I'm trying to make here. And it's after that, it's just a matter of plug and chug. 1000 divided by 1 plus 0.2. Cool. And so $833 you would be willing to give me today so that I can return to you $1,000. That's the whole idea. I'm thinking this is fairly straightforward. Okay. So you'd be willing to give me $833.33 to get $1,000 a year from now. Cool. And this brings us to the rule 3, which is to move money backward, one time unit, divide by 1 plus the interest rate. To move forward, we multiplied by 1 plus the interest rate. To move backward, we divide by 1 plus the interest rate. That's the difference. Cool. Next, one more question. You have $1,000 with you today, and you are expecting to get another $1,000 a year from now. How much total money do you have? Take your TVOM to be 20%. What? You have $1,000 today, and some other way, you are expecting to get another $1,000 a year from now. So how much total money do you have? What? Are you kidding me? It's $1,000 now, $1,000 a year from now. Total money is 1,000 plus 1,000, man. That's 2,000. No, no, it don't work like that, right? What's the idea? Because the two amounts are not at the same point of time. We already said money has time value. So $1,000 today is not the same as $1,000 a year from now. So in order to find how much total money do you have to ask the following question. How much total money do I have today? That includes $1,000 a year from now, okay? Or how much money, total money I have in a year from now? What are you asking? So which point of time are you asking as to what my total money is? That is something that you need to think about. Cool. So this gives us the final discounted cash flow rule, that is rule 4, which is quantities of money cannot be added or subtracted unless they occur at the same point. So what I have done here, 1,000 plus 1,000 equals 2,000, that's a no-no. Because quantities of money cannot be added or subtracted unless they occur at the same time, at the same point of time. This $1,000, the first one, is the present money. And this second $1,000 is a year from now. I cannot just add them like a simple algebra, simple arithmetic. I cannot add them. Okay. And the correct way to find value is uh, either do a present total value, okay, where in first context, this 1,000 refers to what you already have now. That is 1,000. It doesn't have to be moved anywhere. We are looking at a present value. We have at present $1,000. So that just remains put. However, the $1,000 a year from now, we need to pull that back to the present value. That's a future amount. Find what its present equivalent is. And we already learned that in cash flow rule 3, in order to pull money back by a certain period, you need to divide by 1 plus the interest rate. And that's what we are doing. And together that turns out to be 1833. I hope that made sense. Okay. Next. Um, There's another alternative for us. We could find a future value. That means in a year from now, what would be the total value? Well, present we have 1,000. Would you agree that we need to project this forward by 1 year? And then this other $1,000, the second one, it's already in the future at 1 year time point. So we don't need to do anything with that. So we'll take this 1,000 and project it forward by multiplying by 1 plus I. And the other $1,000, which is already in the future, just add it. So that turns out to be 2,200. Okay. This is how you add or subtract monies. You take all these cash flows, going, coming, everything, and put them into one particular time point. Which one? The present one or the future one, or 15 years from now? That's all up to you. But whatever you do, every cash flow, you need to project it to one particular time, and then you can add or subtract. That's the key. Cool. We'll do plenty of problems. So this concept will be drilled into you with so many examples, you will get sick of it. Okay. All right. Now, it's a little curiosity. What happens if we find a total future value based on the total present value? What? This is what I'm asking. We said the total present value is 1833 and the total future value is 2200, right? Hmm. The question what I'm raising is, if we take this 1833, this present value, and project it into the future by 1 year, what would that 1833 give? Let's see. 1833 times 1 plus 0.2, right? To project forward, we multiply by one time unit, we multiply by 1 plus I. And that's exactly what I'm doing. Lo and behold, we get that 2200. Really, should that really be a surprise? I say no, it shouldn't be, because mathematically, let's look at this. Let's look at this equation. If we multiply this equation, the present value equation, both sides by 1 plus 0.2, what happens? The first term becomes 1,000 times 1 plus 0.2, and the second term becomes just 1,000, right? Would you agree with me? 1,000 times 1 plus 0.2 plus 1,000. Well, isn't that what this is? So no wonder even this one, we need to multiply this also by 1 plus 0.2. So it gives you 2,200. Mathematically, it makes perfect sense as to why it turned out like that. I'm a little bit of a math nerd, so I wanted to show that to you. Cool. Alrighty. What else? So summary of the four uh, discounted cash flow rules. Money has a time value. Quantities of money cannot be added or subtracted unless they occur at the same point of time. To move money forward one time unit, multiply by 1 plus the discount or interest rate. To move money backward one time unit, divide by 1 plus the discount or interest rate. Cool. Well, that's the end of the session. Thank you very much.